let's move on to Maciej, the last speaker of our meetup tonight. Maciej is an old timer and has worked in many stacks and languages in the backend, frontend, and mobile ecosystems. He's currently working as a full stack developer in data art, where he switches between Python and TypeScript. And he will tell us about Elm in TypeScript, pattern matching, and beyond. Let's welcome Maciej to the stage.
Yeah, hi everybody. Yeah,
Hey,
so
Maciej, how are you doing? Are you energized?
yeah, I'm trying to be. So I hope my presentation will go well. So it's different from the previous one because I have no slides but the code. It will be
Oh,
not be
nice.
live coding, yeah, but it will be like showcase of the code I have prepared.
All right.
Yeah.
So like I'm super curious to learn about that. If I'm not mistaken, I think Elm was also the inspiration, the initial inspiration for the Redux library. Which, if we have React developers watching this right now, could be an interesting side note about how Redux actually came to be. It was inspired by this unidirectional data flow model that was initially inspired by Elm. So yeah, I'm super excited for your talk, Maciej. And without further ado, I'll just let you go ahead and take the stage.
Yeah, so to have some explanation about this Redux thing, so I will not talk totally about the Elm architecture because the Elm architecture was really the inspiration. I will talk like on the language level, and I will really focus on the pattern matching, which is available in Elm. I hope you see my screen because I have one screen, so so if you can like in the comment that I you see the screen. Yeah, so what you can see here on the left side. So as I said, it will be quite different presentation because on the left side we will have TypeScript and on the right side we will have Elm. So TypeScript will be like a dog and the Elm will be like a rabbit which will running from the dog. So why Elm? Elm is like a purely functional language which I have occasion to work with like half of the year. So yeah, so outside of many features of Elm, Elm has like great pattern matching feature, and it is the one thing I'm missing in switching to TypeScript now. So exactly the why I created, let's say, this talk and why I created a library, which I will talk about, which is really like a pet project more than the library. It's exactly like the fact that I would like to have something which I felt in Elm, so exactly the pattern matching. So what I will be do, I will be like running the dog, and the rabbit will go away with new like with showing more like revealing more features of pattern matching in Elm. So let's start. So the first example when the rabbit is going is really like a simple, totally simple type action, which has like two possibilities. It's all or running or sleeping. So we have two possibilities here, and pattern matching in Elm is made in case of expression. So case of expression looks like we just define on the left element of the sum type, because this is a sum type because we sum possible elements in this type, and we on the right side we are defining what will be result on this member of the sum. I hope at least for me, even if when I was like new for Elm, for me that kind of code and this kind of pattern matching was like clear very much. I mean, there is no really asking what this code is doing, because of course this is only my opinion, but generally for me this like clean code where you see all possible options and the possible results which we can have. So how we can do that in TypeScript? So in TypeScript, like let's start from that. The TypeScript has enum type, and we can like express, like on the left you see the TypeScript, on the right you see the Elm. So we can express as an enum this sum type, and it's really like the same thing on this level. So we can also replace our case expression by switch statement, and that's fine. I mean, that works. This is also readable enough. Of course, we have a lot of syntax more. We have return, we have more brackets, but that's the specification of the language. So I will not complain on that. But what we can do more? So like we can go to the union. So we can do the union from strings. It's a literal union, and we can do the same. So we can say union have two members. It's a run and sleep, and we can do the switch over that, and the code almost look the same. So I left the comment like, what if I removed one option? So the bad part of this is that if I remove the option, nothing happens. So it means that we are not protected in the type level, that will cover all cases. In Elm, it's like always like there is a protection over that. So we need to explicitly put like a wildcard to say that all other options need to have some result. So it's not possible to just omit some options. So here it doesn't apply. But more or less for this simple sum type, we can say that it's equivalent, and it doesn't look very much bad. So on this level, enum or literal type can replace like a simple not parameterized sum, let's say. So what we have next? So the rabbit goes and it's running. So it's running to the point where we have parameterized sum. So as you can see, the type is almost the same, but we have like additional argument, which is like int. And how Elm works with that is that in the pattern matching, we can really say run and do the destructuring over that and say run distance and just use this distance here. So that's really fine because I still can enumerate over all options, and I can use like arguments in here. So still, I think, still it's my personal opinion that this code looks very clear. So how TypeScript can deal with that? So first try is nope, because we cannot have parameterized enum in TypeScript. So this is like compile error. So unfortunately, it's not a case. Swift language has exactly that. So we can have an enum which has additional arguments, but it's not a Swift. So let's go on. What we can do in TypeScript? So let's go in OOP way. So we can have an action class. We can run class which extends action, which has a distance, and we can have a sleep which extends an action. So in this way, we can really do quite the same stuff. So we can check if instance of a run is here, and we use the distance. As you can see, like TypeScript is showing that in this if block, the action is really run, so it's able to make a type guard over that. So that's fine. But as you can see, a lot of burden is here. I mean, a lot of code. So we don't like that. Let's go further. What we can do more with that? So we can make a target union by plain object. So this is a tag, which will be discriminating which option we will use. And again, we can do the switch over a tag, and we can use the distance. So still, as you can see, TypeScript is able to know that in this particular branch of the switch, this is a run tag and it has a distance. So that's kind of fine, but it's very, very verbose. And as you can see, the difference is that here, to make an run, we need to like it's simple as it that type action has a value constructor built in. Here we need to do the raw object, so it doesn't look the same or similar to that, but it's not bad. What we can do more with that is we can change the action into tuple. I mean, this is a like array in JavaScript, but generally we can make like tag as the first element of the tuple and the argument of the second element of the tuple. So this almost looks the same, but this code maybe is less nice because we use index instead of name parameter name. So that's maybe like downside of this approach. And still, if I will remove this case, nothing happens. The compiler doesn't protect us. But constructor is a little bit better than the previous one because it's less verbose, let's say. So it's simple to create such a element of this type. Okay, let's go further. What we can do more? We can do a protection over the switch and really remove, add this option on default, which is using never type. And the never means that we cannot assign the action to never. So if I will remove one option, this will be compile time error. But it's fine that we have it and it's protect us, but still, when we look on this code and to compare that to the right side, it doesn't compare very much because this looks very scary. So we can do better, let's say. So what we can do better, I create here some simple match utility type. Um, what we can do here, I mean, I will very fast go through this type. So we are using sum, which is the tuple, which is or just a tag or just or tag with an argument, and we go over that. So this is a mapped type. So we say that key is a tag. So we go through the tag, and if we check that our element is has an argument, then on the right side we need to have like a function which has argument of this type. Yeah, so if not, it means that this is like a simple element without argument, and we have like just a function without an argument. And I create like a simple case of function which uses this type. I will not go into very much detail, but generally the fact is that, as you can see, this is a simple function which takes like a value on the first argument, pattern over this value. Pattern is really an object, which we'll see in a moment. So how we can use it? In the following way, we have an action which is still a tuple, which has two elements, run and sleep, and we have case of, which this is a pattern which we created in the match type. So we have, as you can see, compiler knows what we have here. We have a run, and on the right side we need to have like a function which have a distance argument which is a number, and we have a sleep which takes a function which has no argument. The string is like a result type because all elements of this case of needs to return the same type. So now let's check what will happen if I will remove one option. Yeah, so that's great behavior because we need to have all options here because this is compile time error. So that's fine also. And what the compiler really shows us here, let's check how compiler help us here. As you can see, it's nice help because it's saying you have a run which needs to have function from number, and you have a sleep which needs to have a function to string without argument. So it shows all possible options. That's really everything which we could do to have the same behavior on the right side. And I'm quite happy from this, and I think it's like type is simple, implementation is quite simple, and the effect is almost the same. Of course, like JavaScript has more brackets, but that's it how it is. So what can we go further with? Okay, so the rabbit is still running and running to the more complicated type. So now we have run with a maybe. So somebody's running, but sometimes we know how long, and sometimes we don't. So maybe treat a maybe as something which represent nullability with in such languages like Elm. So what we can do with that in TypeScript? Firstly, we will use our case of which we created, and unfortunately the type is simple, so we cannot do the flat thing. As you can see, Elm is doing like a flat pattern matching, so I can pattern match over the top element and nested element in the same line, so I don't need to have a nesting. With our simple utility, I need to have a nesting, so I have case of and case of. It's nice, but we could be better. So let's try to run and find a better solution. So as I said, I create some pet project. It's on GitHub. And this pet project I created there a match utility, which is more powerful than the type which we have seen before. And let's create an action, which will be again some type, which have like maybe number as an argument. And let's use a match with. And match with, as you can see, it's like a little bit different because we have two elements of this. So we have match action with pattern. And so that's because of some readability, maybe that's also like, let's say, personal choice. So as you can see, I can make here like almost the same way like on the right side. So I can make a nested uh, pattern matching. Yeah, so I say run just and distance, and this is also, as you can see, compiler knows that it should be a number. So this also knows that it should be function to string, and this also should be a function to string. So let's check what will happen if I remove one option. Yeah, that's compile error. So that's really great. And let's see what compiler is helping us here. So I will just, yeah, so as you can see, compiler is showing like what options do we have? We have run, but if we choose run, we have like maybe number in the argument. So we can do the nested thing as we have done with in the previous example. But we can have run just and run nothing or sleep or wildcard. That's our options. So like fully compiler knows what available options we have. So I think we are also like done here. So this level is totally achievable in TypeScript, and it's, I think, outside of brackets. Sorry for that. So we have like equivalent solutions, but the rabbit will go. Sorry for that. Rabbit will go further and one level more. So Elm can like make more levels. So we have like request which inside have action. So how we pattern match over that still is flat, totally flat in Elm. So I have success, run, just distance. So only for that we have this case. For other cases, we say definitely not running. So we use the wildcard. That's how we can do that in Elm. So still we have flat pattern matching. Can we do that in the TypeScript? With the utility, which I mentioned before, we can do that. We can make the request. As you can see, like representing those target unions as tuples are very, I mean, for me, very nice syntax for that. I mean, it's really less code than tag and additional properties. And amount of declaration of those types is quite the same. Uh, so how we can do that? As you can see, we can do that, and this is like success run just like in the right side. So we can pattern match over that. We have a wildcard also. What will happen if I will remove the wildcard? Yeah, compile error. So we need to have a wildcard or all options here to be sure that it's working well. So now what the compiler will tell me. So all permutations are here in like TypeScript compiler will tell me what options I do have to to make it. Yeah, so and will protect me for having like not all options covered. Okay, so I think still left side is equivalent to the right side. It's compile safety, it's readable, I think so. There are more brackets, but we need to deal with that. Okay, so the rabbit is will running. Okay, so what can Elm do is also he can pattern match over tuples. So uh, there's a result type. The result type is typical way of dealing with errors in TypeScript. This is not a full type because really this is either, which Michael in the previous presentation said about. So we should have like uh, two types here, not one, to be fully either, but it's simplified version. Um, one thing I should mention also, why I using like match with naming and not of case of like Elm has it, because case is like a protected word in JavaScript. So I used match with. So to remember, match with is used also in OCaml language. So OCaml language has exactly match with name expression. Okay, so going back to our example, so we can pattern match over many elements. So in Elm, it looks like for all OKs, we return this is like some implementation which I just created for this. So let's say our function just for all OKs creates a list of those values, and if some of one of those will error, we'll create an empty list. That's just an assumption. How we can do that in TypeScript? So the match utility allows us to use match with. As you can see, I pass here 3 elements, and I can pattern match over that in the same way. So I can say, okay, XYZ, XYZ in the array, and for other cases, empty array. So like totally the same thing we can do here. And what compilers will show here is like all possible permutations of all 3 options. Yeah, so totally achievable in TypeScript. Okay, uh, so yeah, so I think the dog and the, and the rabbit can agree, shake hands. They don't have hands, yeah. So show me the code. I mean, very fast. I will not go into detail, but do you hear me? Sorry.
Yes, we hear you again. Yeah.
Oh, okay. Sorry, because my headphones are like turned off. So I'm here still. Sorry. Okay. So show me the code for a moment. So this is like part of this code. The code looks like that. Yeah, I mean this is exactly the type utility, the match utility you have seen. I mean, yeah, the funny fact is that it has no type level, no, sorry, value level. So it's only type level, but it will be much simpler than that. Work in progress. So how it works, it's used like template literals types, and this is exactly the thing which you see on the end. So it checks if our type inside has again the same type, and inside has again the same type, and goes like 3-level deep. I mean, we could be doing recursive types here, but I didn't want to have like a solution which will be like a problem for the compiler time. So this solution only takes 3 levels deep into the possible option. I think 3 levels deep is enough for most cases. So if you can see, like if we have like nested sum type to the 3rd level, our object in the end is really like first tag, second tag, and 3rd tag, and the function which is like a argument of the third element of the sum. So so the solution is based on literal templates, string templates on the type level. It's quite a new feature of TypeScript. So before it was not possible to even do that. So as you can see, like the solution is based on the mapped types and on the conditional types and on the template literal types of TypeScript. And somehow it works. I don't fully know how, but it works. Okay, so why do I need it? I mean, really, I mean, let's see the React example. Okay, so the Elm will be here, but let's focus on the left side. So typical case of the React, how we create a React component currently, I mean, many people do, is something like that. So we have some props, error can be there or not, name can be there or not, loading is true or false. So it's kind of a little bit a mess in terms of the model which this component can represent. So if an error, we return an error. If on loading, return a loading. If there is a name, we show the name. If not, it's anonymous user. It looks maybe clean, but but it's like it has some, I mean, the code defines that the error is more important than the loading, and an error is more important than the name, because really the props which we have here allow to have error and name and loading. So really the model of the data is wrong, and the code is fixing the model of the data. So we don't want that. And we can do that like better in the Elm style. So we use the match with. We have like our request, which is success, error, or loading, and so this is a proper model of this data, and we say if error, this shows. If success just, we show the name. If success nothing, we show anonymous user. If loading, loading. Yeah, I mean, I think personally this code looks like simple than this one, and this is like the current standard, let's say. Yeah, I think more or less that's what I want to show. But yeah, one thing more here. There are like pattern matching proposal stage 1 currently, and we have tuple record proposal stage 2. Why I'm talking about tuple record proposal? Because better to represent those types here as like tuples, let's say runtime tuples than arrays, because this has like impact that this is really an array which has all functions of array, so it's not a great thing. So if they will pass the tuple to the stage 3, it's quite close. This can be implemented on the tuple level. There is also already existing library test pattern, which is a little bit different than my approach, because I really focus on some types, and this library focus on the like pattern matching of everything. So really powerful. But what I wanted to show is like this mix of pattern matching and the sometime together, and how we can model the state, model the application behavior, like clear state model and what the application does. Yeah, that's thing I think from my side. Thank you very much.
Thank you, Maciej. That was super insightful and really interesting. I'm also a big fan of pattern matching, actually. I feel like this is a much more elegant and just a much better solution to like a lot of the problems that we typically tackle otherwise as programmers. But I'm a big fan of that, and it was great to see how the support of that is in Elm and in TypeScript. All right. Thank you, Maciej.
Thank
We'll
you very much.
talk about your questions next, but I'll let you go. Thank you for joining us tonight.
Thank you.